One of the critical clearances that's so often overlooked or even completely ignored by enthusiasts building their own performance engines at home is the piston deck height. This, simply put, is the clearance between the top of the piston crown when the piston's at top dead center or TDC and the deck surface of the engine block. Knowing this is critical because it's going to affect two things. First of all, it's going to affect your overall compression ratio, and it's also, and probably more importantly, going to affect your piston to cylinder head clearance. And if we get this wrong, we can end up with the piston actually tapping the underside of the cylinder head. It doesn't take a rocket scientist to figure out that that is probably not going to end well. Now, if you are buying a set of pistons custom designed, or purpose designed I should say, for your engine, then it's fair to expect that the deck clearance is going to be suitable, and this is why a lot of enthusiasts don't give it a second thought, completely ignoring this when they're assembling the engine. Now, that may be well and good if you are working with a brand new engine block where the deck height of the block, which is the distance from the crankshaft center line to the deck surface where the cylinder head will seal, is what the factory intended. However, one of the common practices we'll go through when machining an engine is to have the engine machinist surface the deck of the block. And essentially this is a process that will take a small amount of material, typically somewhere between maybe 2 and 5 thousandths of an inch of material off that surface. And this allows the machinist to get that surface back to being perfectly flat, perfectly true, removing any marks that could affect the ability of the head gasket to seal properly. Now, of course, if you have had the engine rebuilt a few times, it's possible that the deck height of the block could be significantly reduced beyond the manufacturer's specifications. And what this ends up with is the crown of the piston sitting proud of the block at top dead center. Now, that in itself is not necessarily a problem. There's plenty of engines that are designed to have the crown poke out past the top of the cylinder, the deck surface of the block slightly. But if we don't have sufficient head gasket thickness and we don't have enough piston to cylinder head clearance, then this can be a problem. So let's have a look at how we can deal with this situation. For a start, let's have a look at the specification on a piston sheet so we know what actually defines what this clearance should be. Here we've got a set of CP pistons for a Nissan SR20, and if we look at the specification sheet, there's a lot of information here to take in. The key piece of information is actually this one here, which is the compression height. As it says here, this is the distance from the center of the wrist pin to the deck. So basically, we're going from the center of the wrist pin up to the top of the crown. Typically, when a piston manufacturer is designing pistons, they're going to work from factory specifications in terms of the deck height of the block, and that's where that compression height comes in. So just because it's there in black and white doesn't necessarily mean that it's not going to need a little bit of work for your particular application. In our case, our SR20 has been decked a number of times, and we're in a situation where the piston is proud of the deck surface of the block at top dead center, but we need to know exactly how much, and to do this we use a tool called a deck bridge. Let's have a look at that. Here's our deck bridge here, which is a really simple tool. All it is a CNC machined aluminium bridge with a holder in the center for a dial gauge. And essentially what we're going to do is zero the dial gauge on the deck surface of the block, and then it will tell us how far above or below the deck surface the piston crown is. Let's have a look at it in action. First thing we want to do here is place the deck bridge across the block. Now, with a cast iron block, these are actually magnetic, but of course on an alloy block, that's not going to be a lot of use to us. So we want to get the deck bridge sitting in a location where the dial indicator is sitting on the deck surface of the block and the feet of the deck bridge are not sitting on top of the piston crown. Once we've done that, we can then zero our dial gauge, and you can see we've done that there. It's sitting on 0. From here, what we can do is take our deck bridge and get it sitting on the piston crown. There are a couple of considerations when we are locating the deck bridge. You can see here, I've got the dial indicator sitting on the edge of the crown, and here we're perpendicular to the wrist pin axis. So the piston is actually going to rock quite significantly. Now that might look a little bit scary at the moment, but the reality is that when the piston expands, it's not going to rock nearly as dramatically as what we can see here. The other location we can use is we can get the dial indicator in line with the wrist pin. Now this means that the rock of the piston is much less prominent. There's still going to be a little bit as we move the piston side to side, but not as dramatic as what we were seeing in the other plane. So once we've got the deck bridge zeroed and we've got it located on the piston crown, it is important to actually move the piston side to side. What we want to do is essentially measure the minimum and maximum values that we're going to see on our dial gauge, and then we can average those two to give us a realistic amount that the piston is either protruding or below the deck surface of the block. In the case of our SR20 there, we're averaging about 20 thou or half a mil of protrusion above the deck surface of the block. Again, not necessarily an issue, but what we then need to do is take into account the thickness of our head gasket. In this case, we're running a 1.0 millimeter or 40 thou head gasket, so it's not really going to give us the sort of clearance between the piston crown and the cylinder head that I like to see. At a minimum, I want that to be in the range of about 40 thou. So to correct this, what we're going to need to do is have a little bit of material removed from the crown of the piston. In this case, we're going to be removing about 20 thou of material to get us back to a situation where our overall clearance between the crown of the piston and the underside of the cylinder head is going to be safe and sufficient.
If you like that video, make sure you give it a thumbs up, and if you're not already a subscriber, make sure you're subscribed. We release a new video every week. And if you like free stuff, we've got a great deal for you. Click the link in the description to claim your free spot to our next live lesson.